Hi, my name is Amir Ishaq, and I'm doing this video series on WebRTC to first remind myself, and second, to help those who have not yet grasped the know-how of developing a browser-based real-time communication using WebRTC. Now, what is WebRTC? First, WebRTC stands for Web Real-Time Communications, and it enables real-time communication of audio, video, as well as data in web browsers without the need for a plugin. However, you are not just limited to browsers only, but you can also write native apps for mobile devices. Now this means real-time communication can actually take place between different browsers, but also between browsers and native apps on mobile devices. So, which are the supported browsers? Let's just go to WebRTC.org and find out. As you can see, supported browsers and platforms: Chrome, Firefox, Opera, Android, and iOS. Now, I have only tried WebRTC in Chrome and Firefox, as well as in native apps for both iOS and Android, basically using a library in React Native. If you plan to implement your WebRTC solution targeting multiple browser vendors, then you may want to look into Adapter.js. Now, there is a nice article that explains Adapter.js, and this article has been written by Serhi Levent-Levy and Philip Hank. This is the article. You can see the link up here, which I will also include in the description. Go ahead, have a look, read, learn, and make use of Adapter.js to target your different browser vendors. It's a good article. Now, when you start learning WebRTC, you most certainly hear about signaling, and signaling itself is not defined in the WebRTC spec. So, what is signaling? Well, there's a very short article which you can read, which explains in a nice way what signaling is in the context of WebRTC. This is on WebRTC Adventures. Gives a good example explaining what signaling is all about. In short, I would say you have two peers, for example browsers, two browsers, different networks, wishing to communicate. They must first discover one another, and only then they will be able to communicate. Of course, the actual communication, the video communication, the audio, the media flow will take place after all the protocols agree. For this, introduces the need for some signaling mechanism, which is explained in that short article. In this video series, we are actually going to build a signaling server, and your understanding through code will become much clearer. Now, in most cases, clients will be behind a NAT, which stands for Network Address Translation, as well as a firewall. In such situation, these clients cannot know their public IP address in order for a connection to be established. This is resolved by the use of a STUN, which stands for Session Traversal Utilities for NAT, and it's a server. And in situation where a direct connection is still not possible, then use of a turn, which stands for traversal using relay NAT, which is also a server, may be necessary. In this case, turn simply acts as a relay server. You may check out this link, which describes what stun, turn is all about. It's good stuff. There is a lot of material out there on WebRTC on the internet if you search, but I'm going to share a few which I've mentioned: adapter, signaling, stun, turn, and a few others. Now, in this video series, we're going to attempt to write an application that will resemble the one on the screen here. You have two peers connected and video chatting. Later, we're going to attempt to do a mobile application which connects and talks to the browser, which is cool stuff. To conclude this presentation, before we jump to code, I'd like to give some credits. I'm using OBS by OBS Projects, obsproject.com, and to record these videos. And I'm using The Legend of Zelda Skyward Sword as background music, which you can follow this link. So let's jump to code. To make things easy, I'm going to use ReactJS to build a UI. So let's head to reactjs.org. Click Get Started, create new app, new React app. Let's scroll down to the command, and let's head back to the console to create our React app. I will name it -1. Okay, now our app has been created. Let's run npm start. Should spin our server. We should be able to get our app running on localhost. You can see there. So now we have our basic React app running. Now we should be able to just leave the server running as is and go ahead and do some cleanup. So I'll go to the src folder and I'll leave the rest the way they are. I just go to Adapter.js. I'll just do some cleanup, remove the logo, compiles, of course throws an error compiling because the logo is in access there. So what I'm going to do is I'm going to remove all of this. We also don't need the class name, so just remove it. I'm going to add a video tag. Let's create a constructor. And create a ref for the video using react.create ref method. So what are refs? Let's just go and read what React defines refs. It says here, refs provide a way to access DOM nodes or React elements created in the render method. So this means that we can assign this variable to the ref attribute of the video tag so that we can use it later. We'll also add the autoplay attribute. So at this point, let's go to render method and write some code to access our camera. Let's start by defining the constraint. Now to get access to the camera, we need to call getUserMedia and pass in our constraint, and if we're successful, a callback to a method called success will be called, and if there's a failure, it will call the failure method. We're getting an error, failed to compile, simply because we haven't really defined the success method and failure method. Let's just do that right now, and we should be able to get access to the camera. Yep, have access to the camera. So what does getUserMedia do? Let's get some definition. It says here, the method prompts the user for permission to use up to one video input device, such as a camera, and up to one audio input device, such as a microphone. If permission is granted, a media stream whose video and or audio tracks come from those devices is delivered to the specified success callback. However, if it's denied, no compatible input devices exist, or any other error condition occurs, the error callback is executed. In our case, it's failure. However, the documentation says that this method, the navigator.getUserMedia, has been deprecated and should not be used. Avoid using it. So what to use? We'll be using navigator.mediadevices.getUserMedia, which uses promises. So we are going to try and do that next. The code will not change much, So what we're going to do is we're going to copy this and paste it down there and comment it out. And then what there is we will just do the media devices, okay, and we'll try to implement using promises, and everything should be okay. So let me just bring this down. So this is using promises. If getUserMedia is successful, then call success, otherwise call failure. There is yet another way to write this code using async and await. So let's comment this out. The video should disappear. Now I'll paste the code using async and await, and as you can see, pretty much the code is the same. So this simply means that success will not be called until this method returns, and if it's successful, it will return a video stream, and then only success will be called. And if anything happens, an error, then failure will be called. However, I will stick to promises, so I'll get rid of this syntax and bring back the promises. So all the code that I'm going to show will be using promises. Well, this is it for this video in this WebRTC Let's Learn Together series, and I hope it was very helpful. Thank you so much for your patience. If you find me to be slow, you may wish to increase the playback speed to say 1.5. You can find that at the bottom right of the YouTube video player. See you in the next video. Bye.